Okay, so square root method. General form of the quadratic is ax squared plus bx plus c equals 0. You might also see it being equal to y. Okay, so another method of solving quadratics is the square root method. It's a very basic version of it. You mainly use this method if the b term is missing. So if it's just this and this equals 0, you can use the square root method. Otherwise, you cannot. Okay? So, first thing you want to do is you want to get just like solving basic equations, you always want to get the variable by itself. Alright? So, if this was just x minus 25 equals 0, what would we do to solve for x? So just as if this was x minus 25 equals 0, you'd add 25. You're going to start off the same way. Plus 25, plus 25. Okay? That's going to cancel, giving you x squared equals 25. Now, we have x squared. Okay? In basic equation solving, addition undoes subtraction, multiplication undoes division, and square rooting undoes squaring. It's the next step. So if you ever have anything squared, the way to undo that is to square root it. This cancels the square. But whatever we do to one side, we must do to the other. Now, here's the catch. That is not correct. Or it's not correct completely. What? Yeah, very good. Plus or minus. Because negative 5 times negative 5 is also 25. The square root of a number is always going to have that plus or minus. So you got to be careful about that. Okay. So, again, don't get intimidated. If this was just 4x minus 64, we would do two things. We'd add 64 and divide by 4. We're going to do the exact same thing. There's just going to be one extra step at the end. So, add 64, both sides. Okay? 4x squared equals 64. Now again, don't get freaked out by the square. Just do it like you would normally do it. Divide by 4. No big deal. X squared equals 16. Now, there's just the one extra step. Well, first we have the square root, but yes, the answer is going to be plus or minus. So that's going to cancel there, and we end up with x equals plus or minus 4. Now, I said this first hour, I'm going to remind people in this hour too. Please make sure you show your work. I grade on partial credit, so you'll get more points, even if you make a mistake, if you show your work. Plus, showing your work usually tends to reduce the number of silly mistakes that happen. All right. So, same thing. If this was just n plus 8 equals 26, we would minus 8 on both sides. And we're going to do the same first step. (26 minus 8 is going to be 18. Now, here's the thing though. 18 is not a perfect square. 16 is, 25 is, but 18 is not. 18 is in between. But we can still square root it. That is also not the correct answer. Okay? It is right, it's just not the best answer because it's not simplified. This would be like leaving an answer of 2/4. 2/4 might be correct, but we want to reduce it to 1/2. Here, we need to reduce the radical. We need to find what perfect square numbers are in 18. Okay? Now, you should know some of these basics off the top of your head, but let's review some of them. So, let's just put square numbers over here. So, 1 times 1 is 1. That's kind of inconsequential. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And so forth. Those are the perfect squares. So you look at number 18. Does one of those numbers go into 18? 9. 9 goes in there, right? 9 times 2. Now, 9 being a perfect square is going to come out. What's the square root of 9? 3. So our answer is going to be n equals plus or minus 3 radical 2. Because this radical simplifies to 3, and that radical stays radical 2. Should be recognizable to you at least. Okay, now in this one, we need to divide by -3. Which is going to give me b squared equals, that's going to be 82. Now, what perfect square is really close to 82? 81. So we know this answer is going to be really close to 9. Okay, 9 point something. This is going to be slightly bigger than 82. So we do this, plus or minus square root of 82. Now, we need to look at this list and see if any of those numbers go into 82. Do anyone go into 82? 82 divided by 2 is 41. Divided by 2 is a decimal, so 4 doesn't go in. 9 times 9 is 81, doesn't go in. 16 doesn't go in. We're done. Sometimes it is going to be not reducible. There is no perfect square that goes into 82. So we just leave it like that. Okay? Next one, same way we're going to start it. We're going to add 5 to both sides. 10b squared equals 12. I forgot to show plus 5 plus 5. We're going to divide by 10. B squared is going to be 6 over 5. So we take square root of both sides. Now, here's the problem. That means b is equal to plus and minus radical 6 over radical 5. We can split that radical up. Now, you've all seen this before. What can we not have in the bottom of a fraction besides 0? In 10. No, we have a negative number. We can't have 0, and we can't have what? Why do you think I'm asking this right now? What can we have? Well, I've said it like 5 times. It's a radical 5. We have radical 6 over radical 5. What can we not have in the denominator of a fraction? A radical. We cannot have a square root. Okay, a cube root. We're not allowed. So hopefully this refreshes your memory. We need to rationalize. We need to get rid of the radical on the bottom. So we have to multiply by radical 5 over radical 5. This is going to get rid of that denominator, radical. So we're going to get b equals plus or minus radical 30 over 5. Because radical 5 times radical 5 is just 5. The radicals cancel. Because you get radical 25, and that's 5. So that's our answer. Whenever we have a radical on the bottom, we must rationalize it, which means multiply top and bottom by that radical. Okay, over here. First step, add 3. 7x squared equals 567. So we're going to do 567. We get 81. This one's going to be a little bit friendlier. Square root both sides. X equals plus or minus 9. So 81 is a perfect square. Now, you could, if you want to take a lot of time to have fun with math, you could FOIL x plus 4 times x plus 4. But this right here is one item because it's in parentheses, right? It's one item squared. Well, since we have something squared equals 441, we can just square root both sides. This cancels that, leaving us x plus 4 on this side and the square root of 441 on this side, which is 21. Now, remember, here's the tricky part. This is plus and minus 21. Okay? So, when we subtract 4 from both sides, which we have to do, we're going to have x equals 21 minus 4. We're also going to have x equals negative 21 minus 4. We're going to have two answers, plus and minus 21, both subtracting 4. So 21 minus 4 is 17, and negative 21 minus another 4 is negative 25. So we have two answers on that one. We've had two answers before, they've just been plus and minus the same number. This time it's two separate answers. So in this one, same way we're going to start, minus 11 on both sides. That's going to give me 3x plus 6 squared equals 324. Now, since this is a perfect square, it's all in parentheses, we can simply square root it, which gives me 3x minus 6 equals square root of 324, which is 18. The puzzle, sir, which question?
Is it plus or minus x? I can't see the board all that clearly.
Okay, we have seats right up front. So we have two different things. We have 3x minus 6 equals plus and minus 18. So we're going to write 3x minus 6 equals 18. And we're going to do 3x minus 6 equals negative 18. Because it's equal to plus and minus 18. It's equal to both of them. So we're going to add 6 to both sides. We get 24. And this, when we add 6 to both sides, we get negative 12. And then we divide by 3, x equals 8. And divide by 3, x equals negative 4.